We have completed chapter 1 in that we're done with new material from chapter 1. But please remember, everything from chapter 1 you will need to still know. So the goal of chapter 2, which is what we're starting today, is the true logic of geometry. Geometry first semester is all about the logic, and second semester is about shapes. It doesn't matter if it's first semester or second semester. You can't say it if there's not a rule to back it up. So up to this point, you have the segment addition postulate, the angle addition postulate, the definition of a midpoint, the definition of a bisector, the definition of an acute angle, right angle, obtuse angle, straight angle, the definition of supplementary, the definition of complementary, the definition of vertical angles, the definition of linear pair. You also have the postulate, if two angles form a linear pair, then they are supplementary. And the theorem, if two angles form vertical angles, then they are congruent. So all of those things from chapter 1 are going to continue to apply. And we're going to be using them more and more to justify something that we say. Today we're going to look at algebraic properties, because properties are also a justification. Just because you did it, just because you remember doing it in algebra, doesn't mean that we could just do it in geometry. We have to have a legitimate reason for that to be able to occur. So we're going to look at the algebraic properties from algebra and how they apply in geometry. So today is the 10th of September. And our topic is reason using properties from algebra. You will notice that it says section 2.5, so chapter 2, section 5. This is a relatively short chapter, but we do spend about 7 days on like 3 sections. So just understand that even though we're starting in section 2.5, we are going to spend several days on the next couple of sections. So what's our goal? To justify the steps of algebra using properties. So the primary goal of all of chapter 2 is to be able to justify steps of some sort. We're going to start with algebra because that's something you're a little more familiar with. So our property list has 1, 2, 3, 4, 5, 6, 7, 8, 9 properties today. The first 6, I would say, are old properties because you definitely have learned those in pre-algebra and algebra. The last 3 I'm going to kind of call new because you might have learned those in algebra. So you'll notice the first column is the property. The second is an example using numbers, and then the last column is an example using measures. Numbers is another way of just saying this is what it looked like in algebra. So if I say here's a number example, that's what it looked like in algebra. And a measures example is what it would look like in geometry. So just a reminder, if it's in red, it does not necessarily mean that is something that you have to write. I just like to back up what I'm saying. So the first 4, the addition property, subtraction property, multiplication property, and division property, are based on adding, subtracting, multiplying, dividing. They're the basic operations properties. But remember the most important thing about all 4 of these, that you are doing the same thing on both sides. And what do I mean by both sides? Whatever you're doing on the left side of the equal sign, you are doing exactly the same thing on the right side of the equal sign. If it is only on one side, it is not this particular property. If it is something different, it is again not a property. So when we did chapter 1, I talked about when we solved equations, I would say subtract 4 from both sides, but we wouldn't actually write down -4, -4. And that is because I was trying to prep you for this part of our lesson. So if we look at the addition property, these two values were equal, and after I added 3 to the left and added 3 to the right, these two values are still equal. So that's another key point about properties. If they're equal to start with, whenever you're done, they should still be equal. Okay, so we're going to look at what that might look like in geometry. So if you know the measure of segment AB is the same as the measure of segment CD, that means they're both 2 or they're both 5 or they're both x plus 3. If the measures are the same, then they will continue to be the same as long as you add exactly the same thing to both sides. So the length of AB, if we add on the length of MN and we still want it to be equal, then we have to add on the length of MN to the length of CD. So here they are, they were equal, and now they're still equal because we added the same thing to both sides. So this is the addition property because I added the same thing to both sides. Okay, so algebraically, if I have an equation that I need to subtract 3 from both sides, sorry for the interruption, I had to go close the door. So the subtraction property, if you were to subtract 3 from the left side and subtract 3 from the right side, then they would still be equal, it just looks different. So again, if you subtract the same exact thing from both sides, whether it looks the same or not, it's the subtraction property. So let's say the length of xy plus the length of yz equals the length of xz. So this might be something you would do using the segment addition postulate. And we want to know, what does the length of xy equal? Well, the length of xy equals the length of xz minus the length of yz. Now, why is that the subtraction property? Because I would have subtracted the length of yz from the left side, and that's why it disappears, and I would have subtracted it from the right side. And so I still see it because I don't actually know what that real number is. I know it's a number, but I don't know which one it is. Okay. The multiplication property, as long as these are equal to start with, after I multiply both sides by 3, they would still be equal. So if I know the length of AB is the same as the length of CD, and I double the length of AB, they would still be equal as long as I double the length of CD. So that's the multiplication property. The division property, if these two are equal to start with, as long as I divide both sides by 5, then it's still equal. Okay. This one might look a little more familiar because I'm going to put some actual numbers in here. If I knew that twice the measure of angle 1 was 180 degrees, and I asked what's the measure of angle 1, you can tell me it's 90 degrees because you multiplied both the left and, you divided both the left and right side by 2. The next one is the substitution property. So you'll always have two equations. Sometimes it's a full-on equation like these are, and sometimes it's an equation in kind of a smaller value. So we did do a lot of substitution in chapter 1. I just want to remind you what the property would look like. So since I know that y has a different value, then I could come over here and replace just the y. So I still have the x, the plus, now the y has been replaced, and I still have the equals in the 23. So as long as you're doing the replacing within the body of the equation, so see how that's right in the body of the equation, then it is the substitution property. So let's talk about the segment addition postulate again. So the length of AB plus the length of BC equals the length of AC, and you also know that the length of BC is the same as the length of MN. You know these two are equal. Since you know these two are equal, I can take the length of BC and substitute it. So now, the length of AB and the plus sign are just normal. The length of BC has now become the length of MN equals the length of AC. So I've just substituted one value within the equation. So that's the substitution property. We know from algebra that you can't have parentheses, so you need to distribute out the parentheses by multiplying through. So you can see that it becomes 4 times x, which is 4x, and 4 times 5, which is 20. The rest of the equation does not get changed because the distributive property does not affect that. Okay. So let's say we have twice the measure of angle 1 plus the measure of angle 2, and that equals 180 degrees. I could do the division property right now. I could divide both sides by 2 and show you the division property, but I want to show you the distributive property. So I'm going to go ahead and multiply each angle by 2. So I have 2 times the measure of angle 1 plus 2 times the measure of angle 2 equals 180 degrees. And sometimes you'll need to do that. Right now it seems kind of weird, like why would you do that? But it could occur down the road. Okay. The next one is the reflexive property. And then there's the symmetric property and the transitive property. These three tend to go together. They're related in a form. So I'm going to try to show you the differences before we start doing actual geometric examples. So the first thing you'll want to notice is that A equals A, like a reflection, like I look in the mirror and I see me. I don't look in the mirror and see my brother. So I look in the mirror and I see me. So this is like a reflection, so it looks the same. It looks the same. Okay. In the symmetric property, you can see that A was up front and now it's in the back, and B was in the back and now it's up front. So it switched them or swapped their location. Swap their location. And then the transitive property, you can see there's a duplicate value here that doesn't appear in the answer, and that's because it ties them together. So these three tend to actually occur a lot more in geometry than those upper 6 do. but we still need to be aware of how they work. And so the reflexive property is used anytime you want to say that the measure of something is equal to itself. And I know right now you're thinking, well, of course it does. Why would you need to write that down? Because remember, in geometry, if you can write something down, you have to justify it. So if you tell me the length of AB equals the length of AB, I'm going to say, well, how do you know that? And your answer will be, because the reflexive property says so. Okay. So let's talk about the symmetric property. So the length of MN equals the length of XY. So I have two segments that have the same measure. And the symmetric property says it really doesn't matter which one you say first, they're still equal. So if they were equal to start with, they're still equal. The length of XY equals the length of MN. This one's really good for when we get to formal proofs. If you prove one way and they really want you to prove another way, luckily this will just flip it around. This property is also really good when you're doing algebra and you're like, I've got to have my x on the left and it comes up on the right. You can flip them and then use that property. Okay, so last one is transitive property, and I'm going to move that up just a little because I'm getting close to the bottom. The transitive property would work something like this, and it tends to occur in angles more than segments, so I'm going to show you the angles. The measure of angle 1 is the same as the measure of angle 2. And the measure of angle 2 is the same as the measure of angle 3. So if 1 and 2 are the same and 2 and 3 are the same, that means that the measure of angle 1 has to be the same as the measure of angle 3. So here is our tying together. I'm going to go ahead and go over these again because these are really important. We use these three a lot. Okay, first, a reflexive property is like a reflection. Whatever value you have, it's equal to itself. And you'll notice that there aren't two different values here. There's one value listed twice. So the reflexive property only deals with one measure. The symmetric property says if two things are equal, you can flip their order. Well, we have two things that are equal, so symmetric property deals with two things. You're just flipping their order. The transitive property has an A and a B and a C, a 1, a 2, and a 3. So there are three different measures that occur in the transitive property. And the duplicate is not part of the answer. So this is one of the things I do when I look at the transitive property. I'm like, okay, how can I make this a word game? The transitive property kind of sounds like train, not exactly, but it's going to work. So the transitive property, so here's a boxcar and the locking mechanism, and here's a boxcar and here's the locking mechanism. So once the two boxcars are locked together, all I can see is the boxcars. So if I lock them together, all I can see is the boxcars. Okay, so let's do a little geometry practice. Use the property to copy and complete the statement. So the reason it says copy and complete, because if you're doing this on your own piece of paper, you should write down the entire question. Now, these are examples. So we do have an example 0. So if you're doing a fill in the blank example, or sorry, fill in the blank notes, you don't have this and you don't need to write it down. And if you're doing your own notes, you don't need to write that down. Okay, so what it tells us is we are to be using the substitution property. So remember the substitution property, I need to know two things, and I need one of those things to have a value I can substitute or replace. So it's really a whole lot like first chapter 1. The measure of angle 3, sorry, that's not right. The measure of angle 2 is 39 degrees. The measure of angle 1 plus the measure of angle 2 equals 124. Do I happen to know either one of those right now? Why, yes, I do. I know the measure of angle 2 is 39 degrees. So the measure of angle 1 is still the measure of angle 1. The measure of angle 2 is now 39 degrees. It still equals, and it's still 124. So that should look a lot like what we did in chapter 1. And that's the substitution property because I've replaced one value. Okay. The transitive property, which is what's next, so you should be back to your notes at this point. So that tells me I should have 3 different values, a duplicate value that's going to tie them together. So if the measure of NO is the same as the measure of MP, and the measure of MP is the same as XY, then these two tie it together. So that must mean the length of NO is also the same as the length of XY. So number 2 says try this one on your own. So what I want you to do is I want you to pause the video and I want you to try number 2 on your own. Okay, hopefully you did well. So the symmetric properties, come up here, says you're going to swap their locations. They were already equal, they're still equal, we're just swapping them. So if the measure of angle A equals the measure of angle B, then the measure of angle B will be equal to the measure of angle A based on the symmetric property. So the goal of this lesson ultimately is to justify the steps of algebra using properties. We talked about what that looks like in geometry. We did some geometry examples, but the overall goal is to do justification for algebra. So the question is, well, why did you do all this geometry? Because starting tomorrow, you're going to do the same thing, or sorry, I guess in your case it would be Monday. You're going to justify the steps of geometry. And so we wanted to show you this today so you can do a little practice, and then you're going to do it algebraically today and go on to geometry. I feel like I'm babbling at this point. Sorry about that. Okay. So this again is an example 0. You do not need to write it down. You just need to watch. So we're going to solve the equation. That's normal. We've done that. We did it for an entire chapter. But this time we're going to write a reason. We're going to justify what we did. Before you were able to just do it. Now I want to know, why are you able to do it? Now I talked about all the things from chapter 1, such as the segment addition postulate, the definition of bisector, and then I talked about the properties, and I said all of these are reasons. And they have to be used to justify things. When you go to write down the question, none of these fulfill a reason for writing down the question. So this is the most important thing you've got to learn for all justifications. When you write down the question, and I ask you, why can you write down the question? It is because it is given. Okay. Why can you write down the question? No matter what the question is, why can you write it down? Because it was given to me. Okay, so you're going to write down the question, which is normal homework procedure, but now why? Because it's given. Okay. Now I'm going to start solving this equation, and we know there's multiple ways to do it. You know me, I like to pick the variable with the smallest coefficient, so I'm going to move it. In other words, I'm going to subtract 4x from the right, and I'm going to subtract 4x from the left. I don't want to see minus 4x. I want to see what does it look like after the fact. So here's the question. What are you going to fill in over here? What did I do to allow line 2 to be 3x minus 11 equals 19? What makes this correct? Because I applied the subtraction property. And you can write just P-R-O-P for subtraction property, P-R-O-P. You may not put sub-prop. That is not allowed because subtraction and substitution could both be called sub, and so please write them out. Okay. So why does line 2 look like it does? Because I applied the subtraction property. Now I'm going to add 11 to the left, and I'm going to add 11 to the right. So why does line 3 now say 3x minus 30? Because I applied the addition property. So please do not write plus 11 plus 11, because when you write addition property, that explains to me that's what you would have done. So please just go to 3x minus 30. If you need to do the plus 11, erase that after you're done doing it. Okay. Another situation, a lot of people will tell me the addition property is just add. No, adding is adding one number to one side, so it's not the add, it's the addition property. Okay. Now we're going to divide both sides by 3, so x equals 10. So why can I now have x equals 10? Because I applied the division property. Okay, quick review. I wrote the equation y because it was given. I wrote 3x minus 11 equals 19. Why? Because I did the subtraction property. I wrote 3x minus 30. Why? Because I did the addition property. I wrote x minus 10. Sorry, I wrote x equals 10. Why? Because I did the division property. Okay, so let's do an example together. So here's our question. So first thing we do is write down the question. 14 times the quantity x plus 1 equals negative 7 times the quantity 4 plus x. Why can I write that down? Because it's given. Oh, look, I need to get rid of the parentheses. So I'm going to do 14 times x, which is 14x, 14 times positive 1, which is positive 14, equals negative 7 times 4, which is negative 28, negative 7 times positive x is negative 7x. Why am I allowed to write that down? Because I applied the distributive or distribution property. Okay, so let's do the next algebra step. I'm going to add 7x to the right, giving me negative 28. And I'm going to add 7x to the left. So 21x plus 14 equals negative 28. Why can I write that down? Because I just applied the addition property. So now I'm going to subtract 14 from the left, giving me 21x, equals, I'm going to subtract 14 from the right, gives me a negative 42. Why can I write down 21x equals negative 42? Because I just applied the subtraction property. I'm going to divide by 21 on the left, giving me x. I'm going to divide by 21 on the right, giving me -2. So why can I write down x equals -2? Because I just applied the division property. For some of you, the arrows will help you a lot more. So I'm going to go ahead and review this one more time, and I'm going to write the arrows. So why can I write down the question? Because it was given to me. Why can I write x plus 14 equals -28 minus 7x? Because I just did the distributive property. Why can I write down 21x plus 14 equals -28? Because I just applied the addition property by adding 7x to both sides. Why can I write down 21x equals -42? Because I just applied the subtraction property by subtracting 14 from both sides. And then why can I write down x equals -2? Because I applied the division property by dividing both sides by 21. So the reason is next to the answer. The reason occurs between the steps. So like if you had written divide by 21 between steps 4 and 5, then the reason goes on 5. So what I want you to do right now is I want you to go ahead and just sit and watch me do this same question a different way. If after I'm done with this second round you like it better, please go ahead and pause the video and rewrite this instead of yours, or you can write it in addition to yours. But I just want to show you that we know from algebra that sometimes people pick different steps. And for that reason, some of the reasons may be a little different. Okay. So first thing out is you write the question. That's always going to be there. 14 times the quantity x plus 1 equals -7 times the quantity 4 plus x. Because it's given, I can't have parentheses, so I'm going to do 14x plus 14 equals -28 minus 7x because of the distributive property. And I like to do left to right. Maybe that's me as a student. I like to do left to right. So 14 equals -28 minus 21x, because I like subtracting the 14x. So I just now applied the subtraction property because I subtracted 14x from both sides. And now I'm going to add the 28. So 42 equals -21x because I applied the addition property because I just added 28 to both sides. And then I'm going to divide by -21, so -2 is equal to x because I just applied the division property. So you notice we both got to -2, or sorry, we both got that x was -2. It didn't matter which method we used, we both got there. Basically, we're the same on the right. It's just that the addition and subtraction properties are flip-flopped because we took a different route. But we pretty much have the same reasons. Now, I know some of you right now are like, hey, x needs to be on the left. Just put it on the left. Well, you can't just put it on the left. It was on the right, it has to stay on the right. But if you really want it on the left, you add one more step, x equals -2, and because you flip-flopped them, you would write symmetric property. Okay, so we can't just put them on the left unless you really kind of work it out so that it ends up on the left. And that is one of the reasons that I try to stick with the smallest coefficient first. It tends to make the x on the left, but not always. Okay, so what I want you to do at this point is I want you to pause the video. You're going to pause the video and you're either going to write down 3t or not write down 3t. It's up to you. But what I want you to do while the video is paused is I want you to try number 4 on your own. So either write it down on your own piece of paper and try it, or if you're using the fill in the blank notes, go ahead and try it. I did go ahead and leave example 3 on the screen, so while you have it paused, you can see that. Plus you have it in your own notes. So please pause the video and try number 4 on your own. So I know you're back because I can hear the video going. No, I just know you're back because you've stopped pausing it so that you can hear me. Okay, so I've left example 3 at the top here so you can see that, and then here's example 4 at the bottom. And I've actually done it 3 different ways so that you can double check your work. I'm going to start with the first one as if I personally, Mrs. Rose Johnson, was doing the problem. So I wrote the question because it was given. I got rid of the parentheses because of the distributive property or distribution property. I took the smallest coefficient variable, which was negative 12x, and I added it to both sides. So 16x minus 20 equals 12 because I applied the addition property. Then I added 20 to both sides. So 16x equals 32 because of the addition property again, because there's nothing that says these can't be repeatedly used. Then I divided both sides by 16 and x is 2, so that's the division property. So if you did it the way Mrs. Rose Johnson would have done it, that's what you got. The next 2 examples, the next example is I have several students every year who tell me, I was told you have to start with the constant and not the variable. So this entire time I've been doing the constant and not the variable. How's that going to apply to my problem? Well, you can still do that. That is definitely always an option. I don't choose to do it that way. Okay, so we would still write the question because it's given. You would still get rid of the parentheses because of the distributive or distribution property. So let's go for the constant, which is a negative 20. So I added 20 to the left side and I added 20 to the right side. So 4x equals negative 12x plus 2 because I did the addition property. I then negative 12x and I added 12 sides. So 16x equals 32 because of the addition property. Divided both sides by 16, so x equals 2 because of the division property. So if you will notice, they are identical on the right. They are different on the left. And sometimes that happens. If you look up at number 3, we had the same properties, we just had them in a different order. So sometimes this happens. I did it totally different and I got the same thing because sometimes that happens. So the last example that I kind of squeezed in here, and I apologize, it is squeezed in there, is what if I stuck with the variable, but this time instead of doing the smallest coefficient, I just did the variable on the left. Okay, so you wrote the question because it's given. You got rid of the parentheses because of the distributive property. You subtracted 4x, so you got negative 20 equals negative 16x plus 12 because you applied the subtraction property. You subtracted 12 from both sides, so you got negative 32 equals negative 16x because you applied the subtraction property. Divided both sides by negative 16 and positive 2 equals x. we're getting the same 2, it's just x is on the right, and it's still the division property. Okay. So please understand that you don't have to do it exactly the same way. When you do your assignment, it's going to be multiple choice, and understand that we have tried to make the key as appropriate as possible. You will probably be expected to upload your work just in case you get it wrong, and we can look at your work and go, oh, that's why they got a different property. So please be prepared to do your work on a separate sheet of paper, and that you may be uploading the work for this question, or this assignment, excuse me. Again, please make sure you email your teachers if you have any questions. Request a Zoom. Make sure your emails are a little more specific than I don't get it. Give us a day that you don't get, or a specific problem, or why you don't get it. Please also email your teacher with your period. It makes it a little easier for us sometimes, because we really do like to look at you when we're talking to you, even if it's on an email. So we look up your picture so that we get familiar with you. So when you come back in October, we know who you are. So have a great day. Have a great weekend. See you next week.